Hello everyone, in this video I'm going to talk about the root mean square value of a function, or in other words the RMS value of a function. So RMS value of a function is defined as root of the mean of the square of the function. So in this one, the order of operations is really important. So we start from the square. So first we start with squaring a function. Then we're going to find the mean value of the squared function. So the mean of the squared function would be integral a to b f of x, the square of this thing, divided by b minus a. That's what we learned in the previous video. What is the average of a function? And finally, we take the square root of the mean value. So we take the square root of whatever we had in the step 2. So square root of the square of the mean. So this is the formula for root mean square value of a function. And the notations that are used for it is FRMS, or sometimes people write this as f square under the square root value of a function. As we have seen, the order of operations used to get this RMS is absolutely important. So there are different ways of writing this formula. Sometimes if you're talking about a function who is periodic, so we can write the root mean square value of a function over a period of t. So instead of having b minus a, we write 1 over t, and of course because it has a period of t, it starts from 0, so 0 to t y square dt, and the square root of this whole thing. It's just an alternative form of writing the root mean square formula. One of the principal applications of RMS values is in alternating currents. Alright, so here we are given an example. So find the RMS value of this function over the interval 3 to 8. So in this case we see that lower limit a is -3 and upper limit b is 8, and our function is given. So we're gonna find the root mean square value of this function. Since we know that root mean square value is given by this formula, so let's just plug in the values. So in this case, our upper limit b is 8. So 8 minus a. So a is -3. So integral from -3 to 8. So integral of the function, square of this function, right? So square root of 2x squared plus 7 and square of this function. So that is given by, so first we notice that square and square root gonna cancel each other, and this becomes equals to square root of 1 over 8 plus 3, 1 over 11, and integral -3 to 8, so of the function 2x squared plus 7 dx. So integral of x squared is x cubed over 3, integral of 7 is 7x, and the limits of integration are from -3 to 8. So in the next step we're going to plug in the limits, and we see that we get 1 over 11, 2 over 3, 8 cubed plus 7 times 8. So we put the upper limit minus lower limit, so -2, -3 cubed over 3, and -7 times -3. So when we solve this and we use our calculator, so overall we get approximately 6.298. So this is the root mean square value of given function over the interval -3 to 8. I hope that makes sense. So in this video, I discussed the root mean square value of a function. In the next video, I will talk about one of the applications of root mean square values, which is in effective current. So make sure you watch that video as well. Thanks for watching.